What's up, everybody? It's Dan from SageMathTutoring.com, and I'm here with a video to help my student with some geometry homework. So let's dive right in. So this actually has to do with slope and the slope formula and things like that. So let's dive in right now. Looking at problem number 13. Write the equation of each line in the given form. Okay, so first of all, we want point slope form. They also mentioned something called slope intercept form. So actually what I'm going to do is I'm going to represent those two forms right away because we need to be clear about what that is. So point slope form is this, where it's y minus y1 equals the slope times x minus x1. And that is perfect for when you have a point called x1, y1. And it's also perfect for when they actually give you the slope or when you have the slope at your disposal. So when you have a point and a slope at your disposal, then you can just plug all the information into this structure. And then it seems like the teacher might be cool with you just leaving it like that, actually. Okay, so that's the point slope form. Now, slope intercept form is such that it's y equals mx plus b, where of course m is the slope and this right here is the y-intercept. Okay, I'll just call it y-int. So that's perfect when you know what the y-intercept is and when you know what the slope is. Now, in case my student needs a reminder, let's say we have a line that's cutting through like that. The y-intercept would be this y value right here. Let's say it's 3 or something, right? Imagine it's 3. So 3 on the y-axis would be the y-intercept. So we have the y-axis and the x-axis right there, right? Okay, so that's the slope intercept form. So looking at problem number 13, we want to write the equation of each line in the given form. So problem number 13 says the line through 0, -2 and 4, 6. So focusing on that, well, first we're going to need the slope because they want it in point slope form, which is this. Now we already have a point. We could just use this point. So we already have what we could call x1, y1, but we're going to need the slope also, right? We're going to need the slope for this. So for that, we would have to utilize the slope formula. Now we have y2 minus y1 all over x2 minus x1. And we're going to call this first point x1, y1, and let's call the next point x2, y2. So if we were to use those points, then the slope would be, I just use empty parentheses for now. The slope would be y2 minus y1, which is going to be 6 minus -2. And we're going to have x2 minus x1, which is going to be 4 minus 0. And that would give us up here 8 over 4. Okay, so that's going to be 8 over 4. And that reduces to 2. So it turns out that the slope is 2, which means that for problem number 13, we'll bring it down here actually, we could start the process of filling out that point slope form right away. We know that the slope is 2. It's going to be x minus x1. And we already sort of established that the x1, y1 is this 0, -2. So therefore we could just say y minus -2 equals 2 times x minus 0. And that would be y plus 2 equals 2x at the end of the day. And I think your teacher should be fine with you just leaving it like that. Hopefully that makes sense. Okay, looking at problem number 14. So with 14, we want this one to be in slope intercept form, which is this one right here. So we're still going to have to find the slope though. So in order to do that, we could say m equals y2 minus y1 over x2 minus x1. And we could call the first point, really there's 2 points to deal with. We have 5, 2 and -2, 2. So I'm going to say, let's go ahead and label the first point x1, y1, and we'll label the second point x2, y2. And at that point, we could perform the subtraction up top. and we're looking at 2 minus 2 up top, and we're looking at negative 2 minus 2, negative 2 rather, minus 5 down below, and that's going to become 0 over negative 2 minus 5 is negative 7. Now that just turns into 0. So it turns out that the slope is 0. So that's the case with that. And then what you'd have to do with this one is update the slope-intercept form to say y equals 0 times x plus b, right? Because that's the structure we need where it's y equals mx plus b. Well, we just found m. M is 0. M is 0, so we could just put that there. But the question is, what's b? Well, in order to find out b, you just have to pick one of the 2 points, and in this case, it's this one. Let's pick that one. And you plug 5 in for x and 2 in for y, and then you just figure out what b is in that case. So instead of y, we're going to write 2. Instead of x, we're going to write 5 because that's the x coordinate right here. And then we're going to have our plus b. Now that turns out to be 2 equals 0 times 5 is just 0. So I think we should be comfortable to just write 2 equals b. So what we've done is we just figured out what b is, right? We just figured out what b is, which means that we can now update the equation to say y equals 0x plus 2, right? Now, at the end of the day, we don't really have to write 0x because 0 times x is just 0, which means that we could actually go further and we could say that y equals 2. Now, that makes perfect sense because if the slope is 0, that means it's a horizontal line. And every horizontal line is sort of this form where it's like y equals some number. All right, so hopefully that makes sense. All right, looking at problem number 15, the line through 6 comma negative 4 with slope 2/3 in point slope form. So that one's actually going to be a little easier than the top one. So once again, we're dealing with the point slope form, which is this one. And in this case, they actually give you a point. They say the point is 6 comma negative 4, and they give you the slope. So we could call this point x1, y1, and this is the slope, right? M equals 2/3. So therefore, if we were to plug that into the red box structure, it would become y minus negative 4 equals the slope, which is 2/3 times x minus 6. So we have y plus 4 equals 2/3 times x minus 6. Okay, so that is the answer to that one. Okay, so now looking at problem number 16, they want us to actually graph the line. So it's y minus 7 equals x plus 4. Now, one thing we could do is just convert this. This looks like it's sort of in point slope form, but we could actually convert that to this slope intercept form because if you convert it to this equation or this structure, it's actually pretty easy to graph after that. So all we have to do to take this equation and turn it into this blue structure is we have to get the y by itself. Now, in order to do that, of course, we could add 7 to both sides, and that would give us x plus 11. Now, what this is saying is that there's an invisible slope of 1 over 1 in front of the x, and the y-intercept is at 11. So when the line, or the equation of the line, is written in slope-intercept form like this, you should always start with the y-intercept, which is at 11. Now, it is kind of annoying because this doesn't go as high as 11, but let's imagine this was 11 right here. Imagine that was 11. And what you would do is then you would put a point there, and then you would pay attention to the slope. The slope says 1 over 1. That means we're going up 1. That's what the top one tells us. And we're going to the right 1. That's what the bottom 1 tells us. So we're going to go up 1 to the right 1. And then we're going to write our next point. And then you could actually keep going up 1 to the right 1, and so on. Okay, you just keep going like that. Next thing you know, you have your line. Okay, so hopefully that makes sense. Looking at the next one, problem number 20. Actually, pardon me, problem number 17. So problem number 17 is a little nicer. Problem number 17 says y equals 1/2 x minus 2. Now that's already written in slope-intercept form. It kind of looks like this structure. So once again, you take note of the y-intercept first, okay? And the y-intercept is apparently -2, which means we're going to put a point at -2. There it is. And then, once again, rise over run, you can think of it, where it's the top number tells you how much up or down you're going, and the bottom number tells you how much right or left you're going. If the top number is positive, you're going up. If the bottom, and if the top number is negative, you're going down. And if the bottom number is positive, you're going to the right. And if the bottom number is negative, you're going to the left. Now, according to this, we have that y-intercept right here, and we're going to go up 1 to the right 2. So we're going up 1 to the right 2, and then we're going to get our next point. And then you can do it again. Up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And then you can just sort of draw a line through all that stuff. Okay. Now, in reality, you actually only need 2 points and a ruler. If you had 2 points and you had a ruler, then that would be enough. All right. So that is problem number 17. Looking at problem number 18. Problem number 18 says y equals 2. And that is, once again, a horizontal line. Anytime you see like y equals some number like that, then that is a horizontal line, and specifically it's a horizontal line that happens to pass through the y value of 2 right here. So we have this horizontal line passing through like that. All right, so that's that one. Okay, problem number 19, the directions say determine whether the lines are parallel, intersect, or coincide. Okay, so what I'm going to say is that there's really a couple things we need to take into account. We need to take into account the fact that the equations could be the same or different, and the slopes could be the same or different, okay? So if the slopes are the same and if the slopes are different will be a question. And if the equations are the same and if the equations are different is going to be a question. Now, we could create like a two-way table here. All right, I'm getting fancy. All right. This has to do with the equations being the same or different, and this has to do with the slopes being the same or different. Now, if the slopes are the same and the equations are the same, then it coincides. The two lines coincide. If the slopes are the same and the equations are different, then it's parallel. And they are parallel. If the slopes are different and the equations are the same, it intersects. And if the slopes are different and the equations are different, we also say it intersects. All right, so sometimes just to break it down like that is super helpful. So looking at problem number 19, the slopes are different. So right away, the slopes are different, and that means we're in this column, which means that they intersect. Simple as that. So for this, we could say they intersect. Problem number 20. We have 5/2 as one of the slopes. And really the equation itself is y equals 5/2x plus 4. Now this one, you might look at this and think that 5 is the slope, but it's actually not, because what you would have to do with this equation first is you would have to turn it into slope-intercept form, so it kind of like resembles this. We could kind of see exactly what the relationship between the two equations are. So we have 5x minus 4 over here. We could divide everything by 2 at this point. It would be y equals 5/2 x 5/2x minus 2. Now notice how this equation matches or does not match this equation, but it is the case that the slopes are the same. So that puts us in this box here where the equations are different, but the slopes are the same. So we know that these two lines happen to be parallel. All right, so hopefully that makes sense. Two lines happen to be parallel. So we'll put a P for parallel. P for parallel. All right, looking at x plus 2y equals 6, y equals negative 1 half x plus 3. So this one right here is already in our slope-intercept form. I think we should do the same with the equation on the left. So the equation on the left already says x plus 2y equals 6. So we could turn that into slope-intercept form by subtracting x from both sides. We would have 2y equals negative x plus 6. Then we could divide both sides by 2. We'd have y equals negative 1 half x plus 3. So then we're just comparing this green box equation to this other equation, which also says y equals negative 1 half x plus 3. So the slopes are the same, right? Slopes are the same, and the equations are the same, which means these coincide. All right, so that's that. Once again, notice how we had to put them both. We had to make sure both were in slope-intercept form first. Okay, looking at problem number 22, 7x plus 2y equals 10. Blah, 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 3y equals 4x minus 5. So I would say let's put them both in the slope-intercept form first. Now this one's kind of annoying, but we have 7x plus 2y equals 10. And what we're going to do is we're going to try to get this thing to sort of look like y equals mx plus b, right? That's what we want to do basically for all these. So you could subtract 7x from both sides. You get 2y equals negative 7x plus 10. Then you could divide both sides by 2. You'd have y equals negative 7 over 2 to x plus 5, actually. So that's the equation there. With regards to the other equation says 3y equals 4x minus 5. We're on problem number 22, by the way. 4x minus 5. So all you have to do this time is just divide everything by 3. So we're going to have y equals 4/3 times x minus 5 over 3. So clearly these slopes are different and the equations are different. So that puts us here, which means that they intersect. Okay, so they intersect. So that's how you do those. All right, write the equation of each line in slope-intercept form. Then graph the line. So once again, slope-intercept form is y equals mx plus b. And we want to write the equation of each line in slope-intercept form, which means we want to make it look like this thing. And then, of course, we're going to graph it. So obviously, if we're going to put the lines in slope-intercept form, we're going to need the slope. We're going to need this m. So that's where you're going to be using the slope formula, which once again says m equals y2 minus y1 all over x2 minus x1. And that's assuming you have something called x1, y1, and something called x2, y2. So looking at problem number 24, we could say that this is x1, this is y1. We could say that this is x2, this is y2. So therefore, what we're looking at is m equals something minus something. I like to do empty parentheses. It's going to be y2 minus y1. Well, that's going to be 6 minus 2. X2 minus x1 on the bottom is going to be 3 minus negative 6. So that's going to be 6 minus 2 is 4. 3 minus negative 6 is 3 plus 6, which is just 9. So we already have the slope at this point. The slope is 4/9. So that means we could update the equation to say y equals 4/9 x plus b. Remember, there's that little b right there. So there's still a b. We don't know what the y-intercept is just yet. Now, in order to find the y-intercept, as I said on the last slide, you have to pick one of the points. Let's just go with the first one. You pick one of the points, plug in the x coordinate for x, plug in the y coordinate for y, and then solve for b. So at this point, we're going to, instead of writing y, we're going to write 2 because that's the y coordinate. Instead of writing x, we're going to write negative 6. So we have 4/9 times negative 6 plus b. Then at that point, we get solve for b, and then b would be, let's see, we have 2 equals 4 times negative 6 is negative 24 over 9 plus b. It is the case that negative 24 over 9 could reduce to negative 8 over 3 plus b. And then if we subtracted, or if we added 8 over 3 to both sides, that would be 8 over 3 plus 2 is the same as 8 over 3 plus 6 over 3, which is going to be 14 over 3. So we just found the y-intercept, which means we can now update the equation with the new y-intercept, which says y equals 4/9 x plus 14 over 3. Now, 14 over 3 is approximately, it's almost 5, actually. It's almost 5, so it's like just below 5. So that's the y-intercept. It's just below 5. So that's going to be kind of annoying to graph, but we're just going to kind of try. All right, so 14 over 3 is just under 5, so that would put us like here. And then once again, the slope tells us how much to go up and how much to go over. So it's a positive 4, so we're going up 4 and we're going to the right 9. So we're going to go up 4, it's 1, 2, 3, 4. And then we're going to go to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the next point is going to be kind of right there. All right. And then you just connect the dots and then you would be done. All right. So that's that one. Okay. Looking at the next one that says we want a horizontal line through 2 comma 3. Now that's going to be easy because the equation of any horizontal line is just going to be y equals some number. Now, it is always going to be, that number is always going to be whatever the y coordinate is here. So the horizontal line in this case could be y equals 3, and that's nothing more than a horizontal line that passes through that y value of 3 on the y-axis, right? All right, so that's that one. Okay, so now we have the next one, which says we want to go through this point, but with a slope of 2/3. So once again, we're going to want to write that in the slope-intercept form. Now, by the way, for the record, that last one where we said y equals 3, that actually was in slope-intercept form. So we did satisfy the directions with that last one, just to be clear, because in reality, this is really saying y equals 0, x plus 3, and then we could just simplify that to that. Now, obviously, this is slope-intercept form. The slope just happens to be 0, okay? So that's the last one. I just want to make that clear. Problem number 26, though, they give us a point and they give us a slope. So the point is 5 comma negative 2, and the slope is 2/3. So the point is x1, y1, we could say that, and the slope is 2/3. So I would say let's use the point slope form for that, and then we'll convert it to the slope intercept form. Now, as you may recall, the point slope form says y minus y1 equals m times x minus x1. And in this case, it's going to be y minus negative 2 equals 2/3 times x minus 5. Now, at that point, we want to convert this into something that looks like that. So a good first step is to just say, okay, so we have y plus 2 over here. You could then distribute the 2/3. You're going to have 2/3 x minus 10 over 3. And at that point, you could just subtract 2 from both sides. You would have y equals 2/3 x minus 10 over 3 minus 2. Now, subtracting 2 is the same as subtracting 6 over 3. So it's minus 10 over 3 minus 6 over 3, which is going to be negative 16 over 3. So that is the equation written in slope intercept form. So at this point, you would have to acknowledge that 16 over 3, it's really like 5 point something. So this is like negative 5 point something. It's kind of similar to the last one, only it's negative. So we have negative 1, 2, 3, 4, negative 5 point something. So it's going to be something right like that. And then you're going up to, so you're up to over 3, 1, 2, 3. So that's like your next line right there. Up to over 3. And that's your next point, I should say. All right, so that when you connect the dots, you end up with something like that. All right, so that's how you do that one. Okay, so for problem number 27, I'd say that's the trickiest one. They're saying, they give us a couple clues. They say, okay, well, the x-intercept is 4, and the y-intercept is negative 3. Now, what that means on the graph, at least, if you were to look at the graph, what that would mean on the graph is that the x-intercept is 4, so that means it crosses the x-axis here, right? So I'll underline that in red. And we also know the y-intercept is negative 3, so that means it crosses the y-axis right there. Now, if you look closely, what you would then realize is that the coordinates of the x-intercept are clearly 4 comma 0, and the coordinates of the y-intercept are very clearly 0 comma negative 3. Okay, so what that is that gives us the means to find the slope. Now we could use the slope formula right here to figure out what the slope is, or we could just count it if you think about it. Think about it. From the green to the red, we're going up 3, so that's 1, 2, 3, and over 4. 1, 2, 3, 4. So that means that the slope, since the slope is rise over run, the slope is actually 3 over 4. We also know the y-intercept because the y-intercept is the place where it crosses the y-axis. Well, it clearly crosses the y-axis at -3, so we're going to have -3 right there. At that point, all we have to do to write the equation in slope-intercept form is to just plug the information in. So we're going to have y equals 3/4 x minus 3. Now, graphing is going to be very easy. All you have to do is just connect these dots that we already drew, and then you should be fine. All right, so that's that one. Okay, so for the rest of the problems, they want the equation of each line in point-slope form. So once again, this is the slope-intercept form, but the point-slope form is this: y minus y1 equals m times x minus x1. And of course, you're going to need your point, at least one point. You're going to need your point x1, y1, and you can pick any point that's on the line for that. And then, of course, m is the slope. Okay, so in other words, in order to write the equation of a line in point-slope form, well, you're going to need two things. You're going to need the slope, and you're going to need at least one point that the line goes through. So looking at problem number 28, well, they give us the slope. The slope is -1/2, so that's actually really good to know. Slope is -1 over 2. They also give us the y-intercept. The y-intercept is at 2, which means that it goes through this point right here. Now, the coordinates of that point are clearly 0, 2. So we could say that we actually have a point that we could call x1, y1. We could say that 0, 2 is x1, y1. So we already have enough information. We have a slope and we have the point that the line goes through, which means we could plug it in here, right? Maybe I should just color code all this in red from here on out because this red box applies to this red equation. So really what it is, it can be y minus y1, well, y1 is 2, and it's going to be m, which is -1/2, times x minus x1, well, that's 0. Now, I think actually the teacher would be happy with you just leaving it like that because the directions explicitly say to write the equation of a line in point-slope form. Well, this is the point-slope form, so we're done. Okay, looking at problem number 29, which is kind of hard to see, but that's right here. According to problem number 29, they give us the slope, which is nice of them. The slope apparently is 3 over 4. And they also give us the x-intercept, which is at -2. So that means that it passes through the x-axis at -2. So it's right here. Now, the good news is similar to the last problem, that's actually enough information for us to go ahead and sort of write down the coordinates of the point. That's going to be -2, 0. So really, when they say the x-intercept is -2, what they really mean is that it's -2, 0. Now, the reason I'm harping on this is because we need a point, right? I mean, if you're going to do the point-slope form, well, you're going to want a point and you're going to need the slope. Well, now we have both. So we're looking at y minus y1. We call this x1, y1, actually. So it's going to be y minus 0 equals the slope, which is 3/4 times x minus -2. Now, I do believe that it's likely that the teacher would be happy with this. If it was the case that the teacher wanted to simplify it further, you could say y equals 3/4 times x plus 2. All right, so I am certain that the teacher would most definitely accept this answer. All right, so we do have to graph that though, don't we? We have to graph that, don't we? Maybe I didn't graph the last one. We're going to get to that in a moment. So for this one though, y equals 3/4 x plus 2. So that we already have a point that it goes through. So then we just have to take this slope into account. Now apparently the slope says we go up 3 over 4. So we're going to go up 3, 1, 2, 3 over 4. 1, 2, 3, 4 right there. okay? So that's where your next point's going to be. And then honestly, if you had a ruler, you could just connect them at that point. Okay, so that's that one. The last one, I believe the last problem was, I'll write it in blue. What was that? Problem number 28. So problem number 28, that was y minus 2 equals negative 1/2 x. So we knew that there was a point at 0, 2, which was right here. And then all you have to do is take into account the slope of the last one. So that's down 1 over 2. So we're going to go down 1 to the right 2, and then we would have this new point. So the last graph for problem number 28 should have been that. All right, so just for the record. Okay, so looking at problem number 30, it goes through the point 5 comma negative 1. It's got a slope of negative 1. So that's actually great because that's probably the easiest one so far because they literally gave us the slope. The slope is negative 1, and they literally gave us a point that it goes through is 5 comma negative 1. So therefore, let me just get rid of these. Therefore, we could very easily plug that information into the point slope form. So let's do it. So we'll call this one x1, y1. So we're looking at y minus y1, which is really just negative 1, equals the slope, which is negative 1, times x minus x1, which is 5. So we have y plus 1 equals negative x minus 5. So at that point, all you have to do is just plot the point. We have the point 5 comma negative 1. So that's clearly 1, 2, 3, 4, 5 down here. And then all you have to do from that point forward is take advantage of the slope. Now the slope is negative 1, but that's really just negative 1 over 1. So what that really means is you're going down 1 and to the right 1. So that's exactly what we're going to do here. We're going to go down 1 and to the right 1, and then we have our next point. And then you can kind of keep doing that and then connect the dots, okay, from there. All right, so that's how you do that one. All right, problem number 31, they actually give us 2 points, which means we're going to have to do something similar to what we did on the last slide. So the 2 points are 4 comma 6 and negative 2 comma negative 5. So what we're going to do is we're going to find the slope of this line first, and we could use the slope formula for that. Why don't we call this x1, y1, and we'll call this one x2, y2. And then the slope is going to be y2 minus y1, which is going to be 5 minus 6, all over x2 minus x1, which is negative 2 minus 4. 5 minus 6 is negative 1. Negative 2 minus 4 is negative 6, and that reduces to positive 1 over 6. Good. And then all you need is one single point, right? Because according to the point slope form, you need the slope, sure, you need the slope, but you also need a point. Well, we already have a point. We could just pick this point. Why not? Why don't we just pick this point, right? Because we already labeled it x1, y1 anyway, and we need an x1, y1. So at that point, you could then plug all the information in. It's going to be y minus y1, well, y1 is 6, equals the slope, which is 1, 6, times x minus x1, well, x1 is 4, and then we're actually done. Now, similar to the last process for the last problem, when it comes to graphing, all you need to do really is plot one point and then use the slope. But in a way, you could actually kind of do something a little different here. You could plot both points. So we have 4 comma 6. So that's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So we have a point right there. We also have negative 2 comma 5. So it's going to be negative 2. It's going to be 1, 2 in this direction. And then up 5. So we have 1, 2, 3, 4, 5 right there. Right? And then all you have to do actually, if you're going to graph this line, is just draw a line in between those 2 points, and you don't even really need to do anything else after that, all right? Because we just graphed the line, simple as that. So for this one, because they already gave us 2 points, you could just plot the points, draw a line in between them. All right, now let's say we didn't have 2 points. Let's say we only had this point, 4 comma 6, and let's say that we only had the slope. Well, we would do the same thing we did with the last problem where we plot 4 comma 6, which is right here, and then you're going to go up 1 over 6 to get to the next point, which is going to be like around here. All right, so anyway, hopefully that's helpful. For my students watching, good luck, of course. Let me know if you have any questions, and I will talk to you all later. Bye.